It went GA December of last year, so there's a bit of information about it. And I have looked at pretty much most of the Synapse information that has been out there. Everybody's got a hobby. Mine was looking at Synapse for a while. And what I wanted to provide to you is the information that I think that is going to be really helpful if you're trying to decide, should I use this? What would I use it for? And what kind of costs that it's going to use it, and also what benefits do I get from it as well. So I wanted not just tell you all about the technical stuff that Microsoft will tell you, but also a lot of the stuff that they won't tell you, which has to do with use cases and things that it does that are good and bad that I think you should know about, because I would have liked to know them when I started out with it. So a little bit about me. My name is Ginger Grant. I am a data platform MVP, and I'm also a Microsoft certified trainer. And because of that, I've got a bunch of certs. I also do a bit of Power BI as well. And I wrote a book on for exam prep for exam that doesn't list anymore, but I'm happy to announce that the book that I am writing with a bunch of my MVP friends on Azure Cognitive Services is going to be out later this year, so that I can update my slides. And if you want to get a hold of me after this, the best way is on Twitter. I'm on there way too much at DesertIsleSQL. And if I also write on my website as well at DesertIsleSQL.com, although I will say that I've been doing a lot of work recently, and so I haven't updated it as much as I might. So let's talk about Azure Synapse. One of the things that if you're starting to investigate it, you'll notice that Microsoft has an architecture slide that they always show, which I'm not going to show because I want to tell you what I think the most important parts are. And the most important part really is figuring out in your world if you need a database or not. And you may say, well, of course I need a database. Well, yes and no. So if I will say that a major caveat here to determine what is going to work for you is to know how much data we're talking about here. Because Azure Synapse is designed to work with different kinds of data and join them all together into one environment, so that if you've got unstructured data, structured data, big data, soon little data, although that hasn't been released yet, it's on the project roadmap, so that you'll be able to integrate fully Azure SQL into it, although not today. And the idea being is that you can put all of your data in one place and access it using the tools that would be best suited for the particular amount of data and given what you want to do with it. So it's built on top of an Azure Data Lake Gen 2. Now, I'm going to be talking quite a bit about Azure Data Lake Gen 2, and I also tend to sometimes talk too fast and trip over my words. So I'm just going to call that ADLS from now on, so you know that I'm talking about Azure Data Lake Gen 2. If you want to create a Synapse workspace, it doesn't take much to do it. Couple of clicks, you'll figure it out. It's no big deal. One of the things that it's going to require for you to do is it's going to require you that you either create an Azure Data Lake Gen 2 ADLS account, or have you attach one to Synapse, because it's a fundamental component of Synapse. No ADLS, no Synapse. It's that tightly incorporated with it. And one of the things that Synapse has also incorporated is this concept that Microsoft is really pushing in a lot of their different products, meaning that compute and storage are separate. Meaning that doesn't really matter where you have stuff stored. If you want to increase the performance, you can. Your data is stored outside of that, so you can stop and start resources, again, saving you Azure bucks, and that will not, your data won't go away. So making those two things separate. It also includes Azure Data Factory. As a matter of fact, it is a branch of Azure Data Factory code, contains most of it. I will later on discuss the elements that are not included in it. It calls it integration. So if you are familiar with Azure Data Factory, congrats, you know now a large portion of Synapse. Unfortunately, if you're like, I want to use the cool shiny new thing and migrate all of my code from Azure Data Factory to Synapse, there isn't a tool that will allow you to do that. obviously it's the same code, but there's no easy way necessarily to migrate it one to the other. You can do it, it's just not easy. And there are different components of the architecture of Azure Synapse, and the prices for these vary. And depending on what you want to do is dependent upon how much it costs. And this gets to be really complicated, especially if you're pricing this out for clients, because you'd be like, oh, well, that'll be really cheap unless we do integration where we use data flows and then it's really expensive, or we decide that we want to use a data warehouse and we leave it running all the time, or, it just sort of depends on what you want to do as to how much it's going to cost you. Generally speaking, just creating it and having it sit around, that's not terribly expensive, but it's doing stuff that actually starts costing you money. And I will talk about the different things than what they cost as part of this as well. So Synapse is actually can be boiled down into what it does if you look at the different pools that are inside of it. And there are 4. And Microsoft went and renamed them. So I'll tell you the old names so that if you are Googling these and you see one of the names, you're like, well, why didn't you talk about that one? The dedicated pool used to be called, we're talking last year, it was called the SQL pool, and it's now called the dedicated pool. It's still the same thing. The dedicated pool was the first component of Azure Synapse that was actually announced. It was announced at Ignite in 2019, and then they came by past like a day later and talked about it. And when they said, we're doing Synapse, they basically meant we are renaming Azure DW and we're calling it Synapse. We're going to add some more features in there. So a lot confuses some people, and a lot of people think if I'm talking about Azure Synapse, I'm still talking about Azure Data Warehousing. And it does that, but it does more than that. The next pool that I'm going to be talking about is the Serverless Pool. The Serverless Pool was called, can't remember what the previous name for it was, but the Serverless Pool is created when you create a Synapse workspace. It's automatically created when you create the workspace. There's no extra pool creation, unlike dedicated pools and Spark pools. And to use the Serverless Pool, it costs you $5 a terabyte for querying. So if as soon as the number of records that you hit gets to be close to a terabyte, it's $5. What that means is it's a very inexpensive thing to use, and it is on demand, so you don't have to turn it on and off. You can just use it when you feel like it. The other pool is called the Spark Pool. The Spark Pool is exactly what you think it is. It is the Spark engine, the open source engine, which was created as part of the Hadoop Collective in 2010. And it was originally created to win a contest that Netflix was having to see who could come up with a better algorithm for picking movies. They didn't win, but they determined a way of loading data up into memory so that they took HDFS data, loaded it into memory, and optimized it. Unlike HDFS, there's not 3 copies that are loaded into memory. So it is a very memory intensive process, and they make it scale. So what it does well is it's a massive parallel processing of your data, and it does something similar to actually what dedicated pools do, in that it splits up whatever tasks that you're giving it into little bitty pieces, depending upon the size of the pool that you create. Bigger the pool, more pieces, etc. And then brings the result back together. So it's very scalable. It's the latest and greatest hot new thing. It is what Databricks is. Actually, Databricks was written by 75% of the code is written by the same guys that are now working for Databricks. But what they did when they developed Databricks is they're like, okay, this open source stuff is nice, but we like money. So we want to create a product, and we want to make it better than that open source stuff that we created, so that people will use it instead of open source. What that means is that the version of Spark within Synapse is not as fast as the version within Databricks, because they've optimized it. So Microsoft is all in on the open source, And Databricks has proprietary versions. And it's for that reason that the code is not 100% compatible between the two. So that's kind of the story about the Spark pools. And the last pool is the integration runtime. This is also created when the Synapse workspace is created. And this is the integration runtime that's used for the ADF or integration portion of it. This is also a Spark pool. So it does take, the thing about Spark pools that people find pretty annoying is, yes, it does take 4 minutes for them to start up, roughly 4 minutes, just pretty much count on that. So when you say, I want the Spark pool to turn on, then you got to wait 4 minutes for it to go. And same with integration runtime, works the same way. You can create integration runtimes that go faster. So that if you want a integration runtime to go faster, you can definitely do that. So is serverless also Spark? No, serverless is serverless, and it is designed to run T-SQL. Spark is separate. Spark runs Spark SQL, which is, well, when they go to 3.0, will be fully ANSI compliant, but serverless runs T-SQL, and it's not the same. And so the integration runtime, basically, you'll watch it run when you do integration tasks. If you choose not to do any kind of integration, no Azure Data Factory type stuff, then you don't get charged for it. So if you don't use it, you don't get charged.
Oh, Ginger, can you hear me?
Yes.
Did you see that link? Can you look at that link for 1 second?
I know serverless is not also. Are you saying that serverless is Spark pool? Because it's not.
I sent you a link. Can you look at that very quick? Open that. I don't know if you read that.
No, I didn't.
Okay.
So Apache Spark and Synapse that Ewan put out.
Microsoft just released on end of March, they optimized the Spark. Actually, it made it C++ or something. And then anyway.
Yeah, but this has nothing to do, this is Spark, and that's a Spark pool versus a Synapse pool. And what they're talking about is something that's not released yet.
Why don't we keep questions and comments to the middle when Ginger opens it up?
Yeah.
Thank you.
Thanks, Jeremy.
So, but to the question is serverless Spark? No, integration runtime is Spark. All right, so what is a dedicated pool? A dedicated pool is a new version of Azure Data Warehousing. And it is the same if you've used SQL Data Warehousing before, it's similar. They did, of course, add some performance improvement. Too bad Reeves isn't here, because if you did, you would, and if you've talked to him recently, you know and this I think is really funny since he lives in, well, I know he doesn't live in Denver, he lives Denver-ish, that he's into Snowflake. And when Microsoft was looking at the performance improvements that they made for Azure Data Warehousing, they looked at Snowflake too. Because for those of you who have worked with it, it's very good. And Microsoft was looking to make the Azure Data Warehouse more performant. So they use that kind of as their guide. So if you don't want to use data warehousing, you don't have a SQL pool. You have to manually choose to create it, and you could create it the size that you want to pay for. It's like what they did is they made it a lot easier, though, to change your sizing. So if you want to go from small to large, you can do that very quickly. But you are charged for every minute that it's running. Not what you're doing with it, but every minute that it runs. Dedicated pools are great if you have data that's over 1 terabyte in size. It's very performant. You can connect to anything with it. It's because it's scalable and separate from the data. So I can, and I've got a pool for data warehousing, and I turn it on and off all the time. And my data is fine because it's separate. So you don't have to worry about running up giant charges, just turn it off when you're not using it. And if you don't have a lot of data, don't use it. It's designed for 1 terabyte or more. I find a lot of my clients, they tell me how much data they have, and they say, you know what? I think Azure SQL will be a better choice. So think about that when you're looking at whether or not you wish to create a dedicated pool. So the serverless pool, that's created with the workspace, and you're charged when you use it. And you can query Azure, you can query data lakes with it, which is what's really, really cool about it. So if you've got data that is somewhat structured in your data lake, you can use a serverless pool and you can query it. And you don't even have to be very smart, because you can just do select top and it'll do that. It'll write the code for you. One thing that you get into when you're going with data lakes is that the way that you have your data structured does start to matter. There are different features that are available with the different way that data is structured. More and more people are using data lakes for a lot of different things. And one of the strengths with Synapse is you can make it your data lake analyzer. So I know that I first used data lakes, and clients would just put all sorts of crap there. You didn't know what it was. It was hard to figure out what it was. And what's really nice with a serverless pool is you can just look at a file, click on it, say select top 10, boom, you see it. Given, and of course the data must be structured. That's not going to work if you got a bunch of image files, but hey, it's a step in the big direction. Now, one of the things that I will tell you that I do with serverless pools is I use them to create a data warehouse that I use for Power BI. I will structure my data for Power BI. I'll create facts and dimensions off of data that I have within my data lake, and I will put it into a folder that, and then point Power BI to it, and ta-da, that's my Power BI engine. So it's a really cheap way, and I've got a nonprofit client that we do that because it's the most inexpensive way that we can create little data marts, and it costs them almost nothing. And they load it up and do reporting with Power BI, which is really what they wanted to do. So again, I'm not talking about huge amounts of data. I'm talking about importing into Power BI, but it works great. With the serverless pool, you can also create your own virtual databases. So let's say that I've got a couple of different files. I can basically create a view, kind of similar to what you might do, say, if you're creating views for Power BI, and instantiate that as if it was a real table and connect that using SQL Server Management Studio. So you can create virtual databases on top of flat files, and you're charged $5 a terabyte for querying, and that's it. So if you want to get into Synapse, it's actually a really great solution for low budget people if you can get away with using serverless pools. Now, is that the fastest database in the world? No. Can you do indexes? No. But hey, you're doing flat files. And so you only pay for the flat file storage, which isn't much of nothing, and you're querying at $5 a terabyte. So kind of neat. So next we have Spark pools. And Spark pools are used for writing Spark. These pools are also charged for when they are on, but like Databricks, they will turn off when they're not in use. Notice I said not in use, not when you're in the middle of using it. So when it defaults for 15 minutes, you can set that to a greater time if you wish. And I notice a lot of people are now moving to using Spark, generally speaking, Python code for doing a lot of ETL because they can make it faster. And they're starting to write Python code instead of doing something like ADF for integration. And I'm seeing that more and more. So I'm honest, I wish I was seeing more ML because I would love to do more of that work, but I see a lot of ETL being done with Spark. And again, if you've got your data already in a data lake because you've dumped it there from wherever you happen to have it live, it's very easy to connect to it in a Spark pool and manipulate it or analyze it and do whatever you want to do. The languages that it currently supports are Python, .NET, or Scala. Notice there's no R there. This is another way that it differs with Databricks. And of course, it's based on notebooks. As a matter of fact, all of Synapse is really based on notebooks because you write your SQL in notebooks as well. And like I said earlier, the code is not the same as Databricks because they are using a proprietary version of Spark So you can't just cut and paste your code and have it work. It is functionally very similar. If you want to know the down and dirty, I did do a session for the LA user groups, which is going to be on YouTube at some point in time, where I talk about the differences between the two. And my buddy Simon over at Advancing Analytics has a pretty funny thing where he is comparing Spark and Databricks. If you know Simon, he's really funny. So check that out on YouTube if you want more information between what the two of them do. All right, so integration runtime. That's the last Spark pool, which is used for integration, aka ADF stuff. And by default, you get one in the Synapse workspace. And the one that you get by default is called Auto Resolve Integration Runtime. And you can choose, of course, to create additional integration runtimes if you want things to go faster. So if you wish to spend, if you just need something to run faster than it is, create a larger integration runtime pool, and then you can have more resources to run it. I will say, when you're talking about pool creation, there is another thing that you can get into. Matter of fact, I was talking to Bob Pusateri, I know some of you may know him, and he was telling me, he's like, man, I can't, create as big a Spark pool as I want to because I've got account limitations. And yes, that does run into a problem. And yeah, just seeing what Don's comment about for Databricks for ETL. Yeah, I know that I think it would be a pain to support, but you see a lot of it. All right, now that I've talked about the 4 pools, let's actually take a look at Databricks. Now you got me talking about that. Talk about Synapse. Okay. All right, so this is my Synapse workspace, just to give you a little highlight here. This is, again, if you're familiar with Databricks, it works the same way in that you create a resource and then you go to the environment. So you'll see here, this is my Synapse resource here. And this is how I get into the studio, which is up there. And you'll see that I've got a number of different pools listed here. So I've got my built-in, that's what it used to be called, built-in pools, which is the serverless pool. And that is automatically created and it's automatically running. And I also have a small pool because I'm cheap. And then I have a larger pool that I call warehouse. And I have a Spark pool. I just called it medium because it's a medium size. It's a Synapse pool. And if I want to know if it's running, I can look at it from within here, or I can look at it from within Synapse as well. And same with my pools, I think. Yeah, this is running because it's telling me that I need to pause it. So, and I just started this before we started up, so I would have something to show you. So this is running now. So here within Synapse, I can also go here to monitor, and I can take a look at what I just talked about. Here's my SQL pools. And it shows that I've got my small pool, which is running. And then I have my larger pool, which is paused. And then my built-in pool is by default always running. And again, because compute is separate from data, I can use whatever pool that I want to with my code. So if I've got a big warehousing task that I know is going to take a lot of resources, I will use my dedicated pool. If I just want to do something that frankly I could get away with waiting a little bit, I'll create another pool and then run my data warehouse on that. So I can be flexible in where I'm running what. And I can do the same thing with Spark pools. Now, one thing with that you do have to keep in mind with Spark pools, though, is that your libraries are pool specific. So if you want to use a different pool, you will have to load your libraries to it. The code difference between converting between Databricks and a Spark pool, again, Databricks is a engine that runs the Spark pool, not serverless. Serverless is only T-SQL. It depends on what you're doing. The data lake the Delta Lake portion is different. It's also running version 3.0, and Synapse is running 2.4 right now. So it's different. So if we look here at my data, I've got a couple of linked services here. And here you see my Azure Data Lake storage accounts. So if you look at this, you see that I've got a data lake, Azure Data Lake storage, and I've got a number of different data elements within it. Now, I've got raw data, I've got curated data. And so I've got a bunch of CSV files here. Let's say that I just want to take a look at these CSV files I got here. I'm just going to do what I would do in SQL Server, and I'm going to just select top 100 rows. And it auto-generates the code for me. And if I go ahead and run it, now this is running on my serverless pool. And this is going to give me the top 100 records in my CSV file. And again, this isn't the fastest thing in the world, but it is a really kind of a cool way to access data from within ADLS. Now, this is also full-on T-SQL. It's not SQLite and CC. No, this is T-SQL. So anything that you can do in T-SQL, you can do here. So, you know, CTEs, windowing, all that stuff you can do on your data that you have in Data Lake using the serverless pool. JSON? Well, it'll support JSON the same way that JSON is supported in T-SQL. And that's so much fun if you've ever messed with that. But yeah, it's the same code. Be the exact same code. Now, it doesn't have the headers automatically. I have to add the headers command, and I always look that up because I get it wrong. By default, it will give you the headers if you use Parquet file, which is another file format that is more compressed, that is recommended for storing data lake information because it's compressed. It'll save you resource space. I can also directly connect to Cosmos DB databases and do full integration on those as well. So I can query Cosmos DB from within here as well. Just make a connection to my Cosmos DB, and then I can write T-SQL against it as I would anything else. So it's, I also here, you can see that I've got integration data sets. So when I've created an integration pool, the data sets that I create here are listed as data sets as well. So if you are familiar with ADF, again, this is looking pretty familiar to you when it comes to source, sync, mappings, etc. So the same sort of thing that you might be, that you are familiar with. All right, anybody have any questions about this, about how this works? Anything specific about the pools before I dive a little bit deeper into the pools?
Can you please check the messages?
What would be the reason for having multiple pools? Because you can have more resources when you need them and less resources when you don't want to spend that kind of money.
Instead of scaling up and down, you mean?
That is scaling up and down, is changing pools. That's how you do it. So you scale up and scale down by picking a different pool.
How about then you pre-allocate them? Okay,
Yeah.
okay.
Yeah. There is no way of changing the size of the serverless pool. It's fixed.
Yeah, no, okay.
But Spark pools, you can also change that you have multiple Spark pools if you wish a pool, something to run faster.
Okay, for example, what I did is I had 100 DTU, change it to 500 from portal. If I were to have two different, how do you say, pools, it's quicker to switch between them?
Yeah.
Oh,
I mean, you can do either way. I mean, either one is supported. But
the code changes between Databricks and serverless. Is it something like reasonable that you can do, or you wouldn't even bother by it? It's too much.
What, converting code? Depending on what depending on the code.
Okay.
So it depends on if you're using a lot of code you've got Delta Lake in it. That's pretty different.
Okay.
But if you're just doing standard, then not so much. got another question about explaining serverless pools a little bit more. Is it similar to blob storage? So what my serverless pool is doing is my serverless pool allows me to connect to my and query my data. So I've got a Azure Data Lake Gen 2 account. Let me show you that here. So what's it here? Yeah, so this is my storage account. So there's another way of doing this. Yes. So here you can see, this is my root. And these are all of my folders that I have within it. So again, this is just ADLS Gen 2. And what I can do with my serverless pool is I can do things like query it. And I can also create databases upon it as well. I don't have one on this one, do I? So I can create a note, so I can use it for querying data and doing a lot of other things. And that's what my serverless pool is for those kinds of tasks. Does that make sense, Scott?
So is it file storage?
So file storage is totally separate. This is just the ability to query your file storage.
Yeah, if I have 3 different dedicated pools, do they see the same data?
If you make them. They're not going to automatically. You have to assign a data source to a pool at a time. You can't assign data to multiple pools at a time. So yeah, so basically, again, compute and storage are separate. Scott, if that makes sense.
Yeah. So a lake is storage and a pool is access.
Basically think about it is that a pool that this is your data storage. I got a USB drive, and then I plug it into my computer, and that's my pool.
Gotcha.
But
So
I thought, like if you create Spark tables or whatever, you can see them from dedicated pool too, right? Vice versa.
No. Dedicated pools are not Spark pools. Spark pools are separate.
Oh, I swear to God, I've seen a presentation when they're showing you create data from dedicated pool and they see it in the Spark pool.
You can choose to access the data, but they're not. You can access pools from other tools, like for example, from within a Spark pool, I can access data that is stored within a dedicated pool or within serverless, but I'm doing that compute within Spark, and a Spark pool is connecting to an other existing pool. They're not the same.
By default, they don't share metadata.
No, you have to connect them. So it's a place where you are going to be connecting to data that you are using. And again, you're connecting to data, but with a dedicated pool, your pool can change and the data can be associated with different pools. So it's kind of gets a little more complicated. Good analogy there, Chris. All right, so let's go back to playing slides a little bit. All right, so that's what basically a workspace, and those are the 4 components that exist within it. So if you want to do data warehousing, you're going to be looking at doing a dedicated pool. Now, if you created a dedicated pool and it's running, anything can connect to it. So Power BI can connect to it. You can use Spark, you can use Databricks, anything that can connect to that data warehouse once it's running. If you are looking to get data to it, then you're probably going to want to be using Polybase to do that, because that's the most efficient way of probably doing that. And this is, again, another reason that Synapse can be a good tool because you can land the data into an Azure Data Lake store and then use Polybase to copy it into your data warehouse. A very, very clean, easy way of doing that using Polybase. Now, it contains elements in the data warehouse that haven't changed from if you're using Azure DW. It's the same thing. So one of the things that you do need to do with the tables that you create is something called sharding. And the way that data warehousing works is it takes the data and busts it up into, I think it's 62 different little buckets, and puts the data and separates the data so that it can do massively parallel construction. So what you're doing when you're doing sharding is you're basically saying where the copies are going to go and what they're indexed on. So there's 3 different sharding mechanisms. And again, this is done on a per table basis. A hash, which is generally done for fact tables or larger files, which spreads them out using a hash algorithm over the different compute nodes. Round robin, which is used for dimension tables, looking at putting them on the compute nodes. It makes it much more expensive when using round robin to do updates. And the last one is replicated, which just basically puts copies on all the nodes. So round robin and replicated are actually probably a very similar, but you are going to need to monitor your data and make it do this when you are loading it up into a data warehouse. So the next thing that's really kind of cool, that is something that was added when data warehousing was added to Synapse, is this thing called workload classification. So data warehouses, of course, are designed to be for massive amounts of data. So some of the queries just take a lot of time. Go against 1 billion records. Even if you got column store going on, it's just a big job. What you can do with workload classification is you can take users. So let's say you don't want your boss to ever have a slow query issue. You can create a workload classification of high, assign his user to it, and so he always gets the highest priority. So you can do things like that so that important tasks will run with more resources or in front of other queries. So you have that ability to pick and choose who you want to win in the resource game of how you want things to go faster. So that is another feature that was greatly enhanced when Azure DW went to Synapse. That is something that will help you improve performance by improving it for the right people or the right tasks. You can set this for users, user groups, and you can also assign hours to it. So if you want your boss to have really high priority between 9 to 5, you can do that. And if after that there is a load process, you can assign it to that. And also you will need to partition your data. This is something the reason I'm mentioning some of these is because talking to Reeves, which is more fun slamming him when he's here. He's always telling me, like what you can do, what you don't have to do with Snowflake. So I wanted, if you are familiar with that product, I just wanted to call out some of these elements because they are different than what you might be used to if you're using that product. All right. So using serverless and Azure Data Lakes, what you can do is you can create virtual databases, which is one of the real strengths. So you can create virtual tables on top of the data so that you can virtually access data as tables, and then those databases are available. Say if you want to use it in SQL Server Management Studio or Azure Data Studio, either one of those, it acts like a virtual database, and you can also access that database from within Power BI if you want to as well. So it is a database that you create on top of flat files, and it's virtual, 100% virtual. Again, if you don't care so much about the performance because it's just never going to be as fast as a SQL Server job, you can make things. You can create a database that is very inexpensive. So if you've got very cost sensitive customers and they don't really want to pay $1,200 a month for an Azure SQL database and they're okay with waiting a little bit, you might be able to get away with creating virtual databases using Synapse on top of your ADLS. And that way you can create databases for very low cost. What ADLS is and serverless will perform best with is if you create use a file format called Parquet. And I always want to put up a butter thing whenever I say that, but Parquet actually is a format that was created as part of the Hadoop collective, hence the stupid name. And it is designed to actually work sort of like column store in that it compresses data in a columnar fashion. So if you have data stored in the Parquet format, it will shrink the data similar to how it does in Power BI, in that it does a dictionary kind of thing. And if there are multiple entries, it will compress it. And so it says, there's 15 of these and only have one entry there. And this means that when you're storing data long term, it's cheaper because you are storing it in a compressed format. Again, if you're creating virtual databases and you are looking at the fast performance as well, if you can partition your data, that will also improve the performance. So if you have this ubiquitous Microsoft example where they have the taxi database, which has data for each day, if you have that stored in a Parquet format and your data lake has folders that are logical, where they are year, quarter, month, and day, that will also further improve your performance of your virtual database because it'll natively use that file structure to determine the data that it needs to use. So you can partition your data within your data lake by putting things in different folders, and that will improve the queries as well. And also use Parquet files. That will be fast. And then once you've got these virtual databases created, then they're fully SQL Server Management Studio compatible. And this is all using the serverless pool. So again, this will cost you $5 a terabyte. There's no turning it on and off. It's just, and that allows you to access and use your flat file data in a way that you may not have been able to do that before. Yeah, the Parquet things. All right. How much concurrency can serverless handle? That depends on a lot about your data. That's not something I could answer off the top of my head. All right.
But the question, basically, if there's two different tasks, it can do them at the same time?
Yes.
Okay.
All right, so a little example for Serverless Pool. This is how I can create a virtual table on top of a flat file. So first I create a virtual database, and I'm calling this one Northwind. And I can, if this looks familiar to you, hopefully it's because you know T-SQL by now. So I'm going to create an external table. And in my external table, I'm going to call that population. And my population table says that that I've got a country code, and it's varchar, and I've got a country name, which is varchar 100, and I've got a year, and I've got population. Now, I'm going to fill up my external table with data from my Azure Data Lake. So here I'm basically saying that I'm going to take all the data that I have within my data lake that is stored in the folder called CSV population dash. So like a bunch of years here, .csv. And I've aliased out my name for my storage location here, and I'm telling it that I have the file format here. These are variables that get set. So this would be how you would create a virtual table on top of the data using serverless. So integration runtime. So this is basically ADF with a few differences. And so I want to talk a little bit about those differences. So in addition to everything that ADF can do, it also has Spark Pool integration. So if you have created a notebook within Spark that does some tasks. You can just fully incorporate that from within an ADF pipeline, just another task. It also integrates with Synapse monitoring so that you can see the performance of how the integration runtime works all from within Synapse. So that means that you're not going to be looking at it through the Azure monitoring, you're going to be looking at it through Synapse monitoring. Couple of differences, which may be a big deal breaker for you. I know it was for something I wanted to do, is it's got no SSIS integration, which is a drag. So if you've got SSIS code and you want to lift and shift that, yeah, you can't use Synapse because it doesn't do that. And I don't know how many of you have played with Purview, which is the latest and greatest data catalog. I can tell you that it is stupid expensive, but if you wanted to do that,
Yeah.
pardon? Yeah, it's very expensive, but it is really cool because it can catalog all of your data. You'll just pay for that. But, and it doesn't have, there's no support for integration runtimes within Synapse with Purview, unlike ADF. ADF does full integration. So Spark pools. So this is using the open source version of Spark, which incorporates scaling depending on how you create the pool. It does, like I said earlier, this is not using the latest and greatest version of Spark yet. I keep on bugging them about it. And I have heard, because it's been on the roadmap to have 3.0 out, but because 3.0 got moved to 3.1 and then 3.2 really quickly, and then there was a bug, all these other reasons, it's not out yet, but it will hopefully very soon. So it does support Delta Lake. For those of you who are familiar with Databricks, Delta Lake is something that makes flat files act more like databases because you can do things like index them and do something they call time traveling, which basically also means that you can create transaction logs on your flat file data and then look at different versions of those transaction logs should you wish to do that. And that is fully supported within Spark pools. It is not supported anywhere else. So I can't create a Delta Lake version of my data within Spark and then look at that in serverless. So that it won't do. And the libraries are all pool-based. So if I create a new Spark pool, I do have to load new libraries to it. And I can configure and monitor Spark pools from within Synapse. Again, you do not get a Spark pool when you create your environment. You get one when you choose to add one. And it has the resources that you choose to add to it. Yeah, Chris, I thought that time travel thing was silly too, but that's what they call it. So yeah, Google that one. I'm like, time travel, really? But and we'll take a look at that. All right, so let's take a more in-depth look at some of the features of Synapse and go kind of further and deeper into some of the stuff that it can do. So, got way too much stuff open here. Really? Not that one. There we go. All right, so let's take a look at some code that I've created from within Synapse to give you an idea of some of the things that you can do. So here what I'm doing is if I want to create a logical data warehouse, these are the steps that I need to perform to be able to do that. Oh, one thing that I wanted to say, if you want to learn Synapse, Microsoft really, really wants you to learn, it. So what they did, if I go to home here, they've got a whole bunch of really cool things that you can do to learn it. So they've got samples that you can use immediately so that you can look at them, just say you have data to play around with. It'll automatically even, look at creating pools for you. It's got galleries of sample code. So if you wanted to look at stuff like doing analysis on open source stuff like COVID data or Chicago safety, you can do that. And this will allow you to just have some data to play with. It also has some built-in notebooks. And the notebooks show you how to do different tasks that you might want to do. Getting started with Delta Lake, if you're unfamiliar with that. Creating Spark tables, which again are separate than serverless tables. And then I've got my SQL scripts. So I can look at basic queries to Synapse pools, here looking at dedicated pools. And here, this is creating external tables, which is what I showed you a slide about. So you can look to see how you create external tables using your serverless pool. So data masking, again, we're talking about T-SQL. So when you're creating a virtual table and you want it to include data masking because you don't want to say, look at the social security number, you can do that. So all the features that you can do within SQL Server are available within the SQL that you can create for a serverless pool going against your data. So I want to look at this one real quick because I want to remember, I can't always look up what the version is to get the headers, and it's telling me here that it's doing, it's cheating, because it'll tell if I put headers, it's like headers comma, then it'll show me what it is. So this is telling me here that if I wanted to get this population data here, the field terminator is a comma, the row terminator is this funky character, the first data row is here, and the quotes here, they're using double quotes instead of single quotes. So just some examples for things that you just want to take a look at some code and run it and write it. You can basically open it. And again, it's warning you down here how much that's going to take, how much that's going to cost you. So really some great stuff. Definitely check out this gallery, which is available here in Home. And get me out of this. Come on. Oh, close. All right. So they changed what they call this as well. The other thing I didn't mention that you can do within Synapse, because I don't think it's that useful, is although I do have a blog post on it, should you want to learn more about it, is you can incorporate Power BI from within Synapse. So I can visualize Power BI from within Synapse. One thing I have to put in a caveat there, I have this particular tenant, which is my Outlook.com tenant. I've had this one for a while. My Power BI tenant is linked to my Office 365 account, which means that I cannot connect to my Office 365 account from my Outlook account. So I can't do it from within this version of Synapse. I've got it set up within that account. But where I do have it set up, I can create a workspace in Power BI, and then I can visualize everything within that workspace within Power BI. That's of limited value. So I mean, yes, that's kind of cool, but kind of, why do you care? Because it's just looking at everything within the workspace. So it's not, you can choose to connect to a Spark, to a virtual table or to a pool, but you don't need to be inside Synapse to do that. So I don't know why or how many people use it. I never do, to be honest with you. And you could only, when you're integrating Power BI into Synapse, you can only use one workspace. So whatever you want to look at must be in a workspace, and you have to specify, I want to look at this workspace from within Power BI, and then it opens it up into a frame. So going back to looking at code. So I've got everything in notebooks because that's how it works. So this would be to create my logical data warehouse, master encryption key, scope credential, and then my data store. So this will create a virtual data warehouse for me. So then of course you can, oh, here it is. If I want to query my data with header, I actually put it in here because I was tired of looking it up. Header row equals true. So if I do this, this will allow me to take a look at my CSV data and actually see the headers on top of it. I don't know why I couldn't remember that much, but I couldn't. So again, anything that I can look at, anything that I could do within T-SQL, I can do within here. So I've got a lot of different elements here. For example, created a stored proc to get some data from sys objects, just like I might want to do. Looking at creating and dropping external tables, and then I can create those tables and use them within within my virtual data warehouse that I would choose to create. So, and all of these are within notebooks. It's how it's organized. So these are all of my SQL scripts. One other thing that I didn't mention is this is fully compliant with source control. So you can add elements to source control. I have integrated mine to Azure DevOps. You also have the ability to integrate to GitHub should you wish to do that as well. So either way you wish to do that, either or you can do that. One thing that's different from Databricks, again, throwing that out there, is that this is my workspace. So if I wanted to say share it with Steve, we can both have access to a workspace by becoming workspace owners. There's only 2 permissions that are available within Azure on workspaces, and if you are not an owner, you cannot do a lot of things. Like you cannot create external tables if you're not an owner. So unfortunately, you almost have to be an owner to do anything, which is kind of bad because a lot of clients don't want to give you those kind of rights, but they're absolutely essential for this environment so that you can share them with other people. So again, this uses Azure security. Everything is within the same tenant. And users must be a member of this tenant to be able to access anything within the workspace. So, all right, so let's also take a look at notebooks and looks at some more Spark kind of stuff. Now, I can also create notebooks within Spark as well, and create virtual tables to that as well. So here I'm creating an external Spark table. So I can create Spark tables, I can create serverless tables, and I can create tables within a dedicated SQL pool. And they're all different and they use different resources. So it can get confusing when you can stick data everywhere. As long as the pools are running, you can connect to anything from within Spark because it's Spark. If I wanted to connect to a Databricks cluster, I can do that within Spark. It doesn't really matter. I can connect to any Azure resource within Spark. If I have a Azure SQL, I can connect to that as well. I do not believe there's any way of doing SQL on-prem. You can also, of course you can with it, integrate. You can connect to on-prem resources with that, but I don't know a way you can do that from within Spark. If there is a way, I don't know. So here's just an example of creating data using a location called raw cities, which is my raw database called cities, telling it that I want to use snappy compression. So I want this to compress my data to improve it, insert it, put in a couple of values, and then select it. And then I'm going to go ahead and drop it. Now, what I need to do here, darn it, I forgot to stop this, is that I forgot to start my pool. So I'm going to go ahead and run it now. So this is going to, I only have one Spark pool because I'm lazy. I don't want to move all my libraries all over the darn place. And so this is going to start that so we can run this in 4 minutes. So I also do have a connection to a Cosmos DB that I can query from within here as well. And this is, I'm doing that using Python. So I'm connecting to my Cosmos DB and querying it using Python data frames. The other thing that I have done here is I've got a lot of machine learning. For those of you who know me, that's not a real big surprise. And the other one thing that you can do with machine learning is not only just write whatever machine learning you wish to using different Spark components, but I also have the ability to integrate an Azure ML account or resource within here as well, which will allow me to use different features and functionality, including within here. What I'm doing is I am using AutoML. And what this will do is this uses a feature included in AutoML that will allow me to have it use machine learning to pick the best algorithm for me. This does take about 4 hours to run, unfortunately. But what it's doing here is this is connecting to my subscription, resource, and workspace. And this is my Azure ML resource. And then I am using it to features within it to run within Spark. So we got that full integration thing going on. And oh, by the way, you can't do that in Databricks. So a feature that it has that Databricks doesn't. So, and the reason that I might want to do this is that AutoML feature is really kind of cool. I also have the ability to use the AutoML portion of Azure ML that I don't even have to write any code with, and I can incorporate that within here as well. So, and this can also use it to, I can also use this to deploy to Azure ML using the managed instances that it provides so that I've got managed Azure libraries for all of my ML. So kind of a bunch of cool features in here. I can do a lot just using straight up Spark though. Here I've got a machine learning component where I am getting data. Now, I had a question earlier on how do I get data from Spark? Well, I can get it from anywhere that I want to. You know, I can get it from public data sources, which is what I did here. I'm getting data from this remote public data source, which is open storage. And this is the New York Times taxi database. So since it's an open storage location, as long as I know how to get to it, I can access that from within my Spark code. And here what I'm doing is I'm accessing data that I have within my data lake. And to do that, I'm saying, go to my data lake, because that's what it's called, and go to my root folder, then go to the raw path and look at my bank.csv file. So, and here's the path, and then I'm loading it here into a Databricks data frame so that I can process and access the data. So I could also do something similar here. I could connect to an Azure database. I could connect to a running dedicated pool. I could connect and use a dedicated, I could use a serverless pool. Anything that I wish to, I can connect with. Especially if it's classified. I can connect to AWS. There's really no, as long as I have the information that I need to connect to an Azure account from within Spark, I can connect to anything. So there's no limits on what you can connect to. So here what I've done is basically using this to do machine learning on my data, to create training data, evaluate models, and do pipelines. A little tip I might want to throw out here for you is that if you are porting code over and it's just straight Python code and you haven't written Spark before, you're going to want to change it so that it uses Spark commands rather than straight up Python. And the reason why is that if you don't use Spark, it won't scale. So yes, I can run whatever Python I wish. It's not an issue. But if I choose not to use these Spark libraries, when I want it to go to multiple machines, it won't. So make sure that when you're writing, Python or Scala code, that you are using the Spark libraries. So this gets to a long list of things that you need to do to be able to fully use Synapse. Not only do you probably need to use Python, a lot of people like Scala, but you also need to understand Spark components and not just those languages natively. So And if I wanted to look at my pool here, you'll see that I've got, looking at scaling, that I've got a medium pool, which goes from 3 to 20 nodes, meaning that depending upon my tasks, I can use up to 10 nodes of allocated resources to my job. And the more resources that I use, the more it's going to cost me. So pretty standard stuff. Now I want to go back to the thing that I was running, which was just creating a Spark and managed table. And it's telling me that I'm sorry, I moved my data. So I didn't get any results on this. So, no, wait a minute, this is fine. So what it's doing here is it's, I'm creating this table. Let me back and go into my Azure Storage Explorer here real quick, so we kind of take a look at this. So if we look at my account here, it's just kind of easy to reference this in a different tool so you see that it's not all Synapse, because again, the most important thing on this is my Azure Data Lake Gen 2 account. So if we look at this, and got my root container here. So again, this is blob storage. And if we look at raw, we see that I've got this cities folder. I do now anyway, because it's going to, because I said if it exists, drop the sucker. And using Parquet, get some data. So these are my Parquet files. So you can't see Parquet files. They don't look like anything that's human readable. So I've just created them here, and you can see that I've created them because this is today. So what I've done is I have taken this area here, said I want to do snappy compression, and I've inserted these records. I said Seattle, San Francisco, Beijing, and Bangalore. And I've inserted those, and then now I can select those and call them cities by my name here. And then I dropped it. Wish I had done that. I'm gonna run this again, and this time I'm not gonna drop it. And the reason why is I want to take a look at it. So this is running this this code, and this is using Spark SQL, which is very close to ANSI SQL. As a matter of fact, when Spark 3.0 comes to Synapse, it will be 100% ANSI SQL. So what this is going to do is this is going to create a table for me. Hold on. Yeah, good, because it's, oh good, it didn't drop it. This is not something that you can do in in Spark SQL. I'm thinking T-SQL here. I got myself confused. But if I look at my Spark tables here, you'll see I've got a table here called cities. And what this is doing is this is using this Spark table that I created, but it's getting data, this data here that I just added. So it's also accessing my Azure Data Lake partitions as well. And I created it and they live right here. So I can create tables within Spark as well. And I've got a number of different ones. So I've got a Spark database that I created using Python code as well. So any questions about this?
Not exactly about this, but then like what I was thinking is we are dumping a lot of raw files from the source systems. There are multiple, right? And today, unless we do a lot of cleanup on this data ahead, they are not kind of usable. That's why whatever we create at the end, some kind of a star schema, the numbers are matching and everything is accurate. And how do we like we cannot just simply query the files. Like how do we do that? How do we manage that?
Well, management of a data lake is getting to be a really big deal because it's very important that you have your data organized in a way that's easy to do. Because it's not. It's something that people screw up all the time. There's and having a well-organized data lake is really important. I know that. Did you guys have Horner do a talk on that? Because Jason's
last year sometime. Yep.
Yeah. Because that's something that I know that he gets into. And I know he's got a recording of it out there because I looked at it by accident.
I understand the organization, like locating the files and then accurately finding the files. That's not the question. My question is basically the way the raw files are, unless we kind of do all the manipulation we do in SQL against the raw files and create another raw file or something, we can't really use them the way they are.
No, you're going to have to modify the files so that they are in a structure and a format that works best for this application you're using them for. And so you would need to do that if you're going to be Polybase as well.
Okay, where do you do that? Do you do it in ADF? Like,
well, it depends. If we're talking how big the files are, because if the files are massively huge, no. If you do it in ADF, they will time out and it'll never recover. So if you've got to manipulate a terabyte, you better be writing some code in Spark to do it. If it's not that many records, yeah, sure, you can do it in ADF.
I mean, the size is not the concern. The size is not the concern. The complexity of processes the data goes through.
Well, it is actually a concern because if you've got a lot, it will time out and you can't do it. I ran into that. So it does matter which tools you use because some don't work. And you're going to need to write again, this is no different than if you're writing data warehousing code. You know, how do you go from an ODS to a data warehouse? You write code for that and you run it.
And if you write the code in SQL, you generate the SQL code, this and that. It's kind of like, you know what you did versus like, I'm not that comfortable working with the files yet in a Spark and this, and you see, it's too much coding. It feels like I'm not defining what I want and I'm trying to do it. Like, you know, SQL is like a definition. That's, yeah, I kind of like I had a, I don't know. Okay, I'm not sure.
Yeah, I mean, that just gets into like, you know, how to do that. All right. Traditionally, Spark-based data can't be in place updated. Can you update and delete rows here? It depends. What data are you talking about, Jeremy? You want to get more specific and I can give you a better answer?
Sure. So I work daily with HDFS-based data, right? Parquet, Orc. If I want to update or delete rows, I have to rebuild that partition or the lowest, you know, partitionable piece, right?
Yeah.
So I'm wondering, how do you go about doing that? What is the method to do that here?
So again, it depends also on the format of your data, because it may end up in Parquet, but you may not start out in Parquet. But yes, if you can't in place update it. So you're going to have to figure out if you create a new record, say you need to like fix a day's worth of data, you would need to remove one of the files and replace it with a new Parquet file, say if you had to reprocess it. So it's no different than the process that you're talking about now.
Same mindset then. Okay.
Same, yeah. Now, if it's a CSV file, different story. I can tweak those.
If the cost is the concern, for example, right? And if 4 terabytes is more than enough, like a 16 CPU Azure SQL database without even discounts is like $2,000. Is it still cheaper than that, this one? A month?
Depends on what you scale it to. Because the cheapest data warehouse is, what is it, $1.25 an hour? So I don't know how many.
Something or something, 250.
Right. So, but you got to figure.
No, serverless. I'm thinking about how much serverless would cost for like a
serverless is 5 terabytes for a query.
It's only for query, right?
Yeah.
It's a month.
Oh, okay, that's very cheap.
I'd
Yeah.
like some other folks to have an opportunity to ask some questions. Thank you.
So I had a quick one. This table you created for cities, what's it available to? Like, what else can get to it? Is it just things within the analytics, within the Synapse Analytics workspace, you know, the ADF there, or is it exposed to other applications, whether it be Power BI or something like that? I'm just struggling to figure out like how this is accessed.
While you can, I wouldn't recommend it because I have to keep my Spark pool open. So generally speaking, I would do that and then probably put it somewhere. It depends. I would put it somewhere where I wanted to use it. Like I would manipulate it within here and create this table for it. And then I would probably in serverless access this area and put it in my serverless warehouse so that I can access it more cheaply.
So this is more of an intermediary step, just kind of to shape the data so it's easier to push to a final destination?
It depends, because if you're doing everything in Spark and Spark is that, and you've got your cluster on and you're accessing it from there. Yeah, but it can be an intermediate step. To be honest, what I do is I basically use it so that I can create it with a serverless, that I can use it with a serverless pool. So that I want it, so I put it in my virtual warehouse. I don't generally do much stuff within here. I create the virtual data marts within serverless and access it there. And I can do that from stuff that was created using Spark and shows up in these pools. Because all I have to do now is I just have to access this data. So for example, I'll show you what I mean. So this data here is here, so I can query this. And I would probably use CTOS to create a table in my virtual warehouse, but using the data that I created within Spark. And then I could access it from wherever I wanted to. I don't have to have it running for that. Make sense? Does that answer your question?
Yeah, thanks.
Okay. Any other questions? All right, just wanted to like review this before we do all the questions. I know that when I talked today, I showed you, wanted to get a good broad understanding of what you could do with Synapse. We took a look at the 4 different pools, discussed the different things that those different pools do. We looked at, Azure Data Factory elements and how that's incorporated within Synapse. And we also talked about the different ways that you can price things so that you know how much things are probably going to cost you, so that you have a better understanding of what this makes a right tool for you to do. So, all right, with that, any other questions? I know I think I've talked through my time, so. But if you have any questions later on, feel free to hit me up on Twitter. And I also saw somebody that requested me on LinkedIn. I'm sorry I didn't answer that one, but I will definitely connect with you on LinkedIn as well. I will say though that don't feel slighted if it takes me a while, because I'm not on there that much. So thank you very much. I really appreciate having the opportunity to present to you, and hopefully you learned something.
Yeah, for sure. It was fantastic, as always.
Oh, thanks.
I appreciate that.
Yeah.
Just a great overview, right? I mean, a lot of things change on a regular basis up in Azure, so it's great to have this. I've not seen the new stuff in Synapse, so it was great. Greatly appreciate it. So thank you.
Yeah, and one thing I will say is MVP Summit was a few weeks ago, and while I can't talk about that, what I will say is that a large portion of this overview is going to be out of date in probably 6 months.
That's great.
Yep. Well, that's why we got into IT, right? The continuous change,
exactly.
continuous learning.
Right.
It's never boring.
Yeah. No, never boring. But yeah, some of the things are going to change significantly. and whenever they get around to releasing it. So,
Interesting.
and I don't know when that is.
So I think that hits on the fact that they're really putting a lot of energy into this. My sense is that Microsoft is really like, this is a big thing and it's going to evolve rapidly.
Exactly. So when this went GA, it went GA on December, I don't remember if it's 5th or 6th, and Satya Nadella was talking about it.
Right.
So that's the release. They did like a big data thing, and this was the big announcement that, oh, by the way, Synapse went GA. And these are all the things that you can do with it. And this is why Microsoft is so awesome. But yeah, and that was like a 3-hour deal.
Yeah.
So they're putting a ton of resources into this.
Yeah.
If somebody like asks you like Snowflake versus Synapse, what would you say? This like a couple things about Synapse is better about.
Okay, so what I will say is Snowflake is a very good large data warehouse. And they're very good large data warehouse.
Terabyte, 10 terabyte, petabyte.
Yeah, very
Okay.
good. And it is the way that they have created it. You don't have to know as much to make it work really well, which is a big feature on it. So if you are only looking for the bestest database in a data warehousing space that goes really fast, that you don't have to learn a lot on, I'd probably pick it, honestly. But what are you looking for? If you are looking for a way of organizing all of your data, whether it be flat files in a data warehouse, and you want to do ADF, and you want to do Spark, then you're talking about an entirely different use case, and that's what Synapse is good for.
Does it have like a predict within SQL and stuff like that or not?
Yep.
No.
All of it. Yes.
It does too. And what
Yep.
about expense? Which one is compare the costs?
Well, again, how do you compare? Again, because these aren't the same tools. Snowflake is a large data warehouse that is used for doing data warehousing things. If that's what you want to do, it's probably a better choice for that. This does more.
Okay, but I mean, Synapse can go pretty large too, right? I mean,
it can, yeah, it just depends on what you want.
Okay.
How would I compare this to Redshift? Redshift is really pretty awesome. But again, it's only a portion of what it can do. So I think Redshift is actually closer to Azure SQL in its feature functionality. And I think it's a very good tool, relatively inexpensive. But you know, hey, it does what it does well. So a better comparison would be Athena. What's Athena?
So similar.
Yeah, Mark's right. I'm thinking about it differently, right? It basically is like you can take anything, you feed it in S3 buckets. Mass amounts of CSV files, we put them on S3. You can query all those S3 buckets basically through Athena, and it scales depending on how much data you put in there, basically. So, and
that's AWS's feature comparison product. So you know they're trying to match each other up for sure.
It's nuts, like the number of new stuff that comes on all the time. I just got like cloud practitioner certified. I already found out like 8 things in that test that were incorrect in the study that I was doing, because everything changes so fast. So. Right.
And would you say the optimizer in Synapse or in Azure and SQL, is it ahead of them or similar?
For what?
Basically figuring out how to come up with the execution plans.
So Athena doesn't really do execution plans. It doesn't really care about that. It's a flat file aggregator is all it really is. And they're constantly tweaking. What you're doing is you're scaling out, not scaling up. And you're throwing a bunch of EC2 instances in the background that you don't see to give it more horsepower to process through that data. Is what it's doing. So I don't know. I'm pretty sure that's what Synapse is doing too, but I don't know for sure.
Yeah, yeah, you're not wrong. But again, see, that's one of the things is that there's a lot of people that don't do data warehousing and use Synapse. And then there's people who only do data warehousing and use Synapse. So it just depends on what you want.
I got to say, I mentioned before, I work with Spark a lot right now with my current client, and what I saw tonight really excites me to see a better managed big data appliance. Oh my gosh, and not having to deal with bash scripts up the rear. I'd much rather use Python in a notebook or ADF or something to manage those and not have to look a million places to find what went wrong, which something always
because
goes wrong.
I didn't get into much of that, but I mean, the monitoring is really pretty extensive too.
Yeah.
Oh yeah. And that's one of the things that they updated not too long ago. And it shows you like down to the line. It's incredible what you get with monitoring. So definitely
Mark, who's the guy from Microsoft who used to live here in Denver? Kevin, what was his name?
Cox.
What now?
Cox.
Yeah, Kevin Cox. Todd and I went to a SQL Server lunch one time, and it was just him and I and Kevin Cox. And Kevin, I think, gave us a preview of this because he was talking about how you have these Chinese websites he was just getting into Azure, and he was talking about these Chinese websites he was servicing, trying to get their data like analyzed and things like that. And they couldn't, nothing they could do would hold all their data. It was like petabytes a day, basically. And what he was saying was that they just gave up on storing it in any type of database and just started doing flat files and just querying the flat files. So this sounds exactly like what he was talking about.
Well, you could also do that with HDFS. That's also big time HDFS thing too.
Yeah, so there's probably early days of this kind of architecture is what it sounds like. It's
because it's funny because you can use again, because with Spark you can access HDFS, but it's not generally speaking what people are using it for. I don't know. I don't see much HDFS anymore. I used to, but people are kind of like, hey, that's a pain in the ass, and gone with Parquet instead, which I get is still HDFS, which is still Hadoop, but still.
Yeah, and it was all custom code is what he had said. Like they didn't have a real engine to do any of it.
Yeah.
Which was really interesting at the time. So
you have a lot of companies, larger companies that have such a massive outlay of HDFS based technology and they don't see a way out.
Yeah, well, there's that aspect of it.
Mm-hmm.
You know, thinking about this, I didn't mention this either, is that one of the things that Microsoft did is that they put a lot of money into cognitive services, and a couple of things that cognitive services does well is like goes through giant piles of crap and tells you what you've got in there. Picture files being a big one. And they actually created an additional open source Spark library so that you can more easily call those resources to help you sort through your data a little bit better too. So, because people have got so much data, and especially if you're talking about images, what do you got there? So.
Well, I think we'll go ahead and wrap things up. Once again, Ginger, fantastic, great information, greatly appreciate it. And for everybody else, thank you for attending and participating in the conversation. Much appreciated.
Yeah. Really like talking to you guys and looking forward to the next time I can get up there and speak in person.
Or if we want to log in, register next month for the Data Saturday, we can see it.
But Woody's going to do our keynote.
Oh, fantastic.
Oh, nice.
Yeah.
I'll be there.
Okay, good. Right.
Awesome.
Well,
Well, thank you so much. Really appreciate it. Talk to you later.
Thanks, Ginger.
Okay,
Bye-bye.
Thanks, Mark.
Ginger.